Hello, everyone. Thank you all for joining us today on this webinar by Impetus Technologies. The title for today's webinar is Apache Spark, Empowering the Real-Time Data-Driven Enterprise. This webinar by Impetus StreamAnalytix team will help you understand how Apache Spark has become the de facto choice for stream processing and machine learning today in the enterprise. I'm Pankaj Bagzai, Senior Manager of Marketing at Impetus Technologies, and I'm your host and MC for today's session. A quick introduction of our speakers today. We are delighted to present with us on the webinar today our guest speaker, Mike Gualtieri, VP and Principal Analyst at Forrester Research. Mike covers key technology and platform areas like big data and IoT, Hadoop or Spark, predictive analytics, streaming analytics, prescriptive analytics, machine learning, data science, AI, and emerging technologies that make software faster and smarter today. He's a frequent speaker, as many of you would already know. He's a frequent speaker and sought after evangelist and thought leader at industry, corporate, educational, and technology events for his insightful and energetic speeches. Our second speaker is Anand Venugopal from Impetus Technologies. He's the AVP and Head of StreamAnalytix, our enterprise-grade streaming analytics platform. He has over 20 years of experience in software innovation and business development, especially in the enterprise and telco space, and is also a regular speaker at conferences and webinars. Without further delay, let me invite Anand to go over the agenda and take over the presentation. Anand, over to you.
Thank you very much, Pankaj. Good morning, good afternoon, good evening to our audience, wherever you are, whether you're listening live or a recording of this. It's our pleasure to be here today. And one thing I'd like to mention about Mike, it's a privilege to have him here with us today. He's one of the biggest, world-renowned big data influencers. And having that kind of knowledgeable evangelist and person who's talking to leading enterprises every day, being with us is a great privilege. So thank you for being here, Mike.
Sure thing.
We're going to quickly, Mike's going to cover streaming analytics, the business value, the use cases, the blueprint of the architecture, and he's just completed writing a Forrester Wave for the streaming analytics sector of products. So he's going to cover some of that as well. And then we finally get into Spark and why Spark is so special. And we then get into the Impetus portion of the presentation with StreamAnalytix, Visual Spark Studio, and we kind of land it to the ground and see what real enterprises are doing and how they're getting value with this technology. With that introduction, I'd love to, maybe I'll say a few words about Impetus so that you know who is bringing this webinar to you in case you're new to us. So Impetus has been around in the U.S. since 1996. We've been delivering mission-critical technology solutions that are directly impacting revenue and top line of large enterprise customers and technology companies since then. And we actually got founded in India in 91. We have now evolved to become a big data products and services company where pretty much Fortune 100, Fortune 500 clients are trusting us as their strategic partner. 1,800 people strong. We keep growing every week. And there's a very unique aspect of this products and services. We were originally just a services company, and now we've started doing big data implementation since about 10 years now. And those have taught us lessons that we've incorporated into creating products that are independently run as independent product businesses, and StreamAnalytix is one of them. So that introduction, I will move on further. So I think it's a good time to bring in Mike, and over to you, Mike. And the one thing I'd like to tell the audience, please feel free to keep sending your comments live on the chat window, on the Q&A window. We'll be seeing it. We'll try to bring it into our speaking, into our cognizance, and address those thoughts and questions that you are bringing forth, okay? With that, again, over to Mike.
Thank you, Anand, and welcome, everyone. My name is Mike Gualtieri, Principal Analyst at Forrester, and I cover big data platforms and advanced analytics, and that includes streaming and machine learning. For years, I've been talking to development teams and enterprise architects about Apache Spark, about Hadoop, and the big data platforms. And there's certain themes that have begun to arise in recent years, and that is what we're calling the real-time enterprise. So what I want to do is I want to share with you some of those business drivers, what companies are trying to do, and then specifically why they're turning to Apache Spark. So technology needs to be aligned with the business priorities. And when we survey our customers, well, actually, this survey is of global data and analytics decision makers. So these are specific people that are concerned with data. And you can see improve experience of the customer, improve products and experiences, reduce costs, improve ability to innovate. And these are aligned with the general business priorities as well. You know, the problem has been, you know, big data has been a boon to innovation in data and analytics, but a lot of firms are struggling to analyze that data, but most urgently to turn that insight into action in real time. Now, before we get too caught up on what real time actually means, let me just level set that. Real time means business time. So real time is different based upon the application. If you're doing algorithmic trading, that could be, today it could be actually microseconds. But if it's a shopper walking into a mall with a mobile app, it could be a number of seconds. So real time means business time, the amount of time necessary to take business action. Now, when we think about some of the business applications for real time and why it's so urgent, things like customer churn. You know, it's important to note that most large enterprises, they actually have millions of customers, and it's really difficult to try to scale hyper-personalization and actions in real time. So companies don't want to just do a churn model this month and then look at it next month, but, you know, can they do it in real time? Certainly making offers in real time, whether it's what movies to watch, what upsells to make, that's an important application. And even in the automobile industry, we're seeing analysis and models being built, not only to determine if there's some danger ahead, but then also to warn other cars behind this car. Wall Street is using it to monitor social media. Obviously, if there's a trading opportunity, that trading opportunity happens in real time. Cybersecurity and fraud, detecting customer service problems before they occur, and certainly IoT, predicting machine failure. Every business has a use case like this, and every business has a use case where they want to predict or detect some urgent situation that they can act on. And when they can do that with the preponderance of their use cases, that's what makes them become a real-time enterprise. And again, that's why Spark has become an important platform to analyze that data, build models, and do streaming. So analytics is at the heart of this. And the type of analytics that an enterprise needs is, it's not just about real-time analytics. It certainly is an important aspect of it, but batch analytics. So it's still important to do business intelligence. It's still important to do machine learning. These are typically batch analytics. There are some real-time machine learning, but you use descriptive analytics to ideate, to hypothesize about potential use cases and application. You build models, and then you need to deploy those in real time. So the left half of this diagram, this is what most companies have focused on in the past. What they need to focus on is also this right side here to detect and then adapt those applications. Of course, analytics is nothing without data, but let's make some observations about data today. I thought this was fascinating. I mean, we know that the data is growing tremendously, but what's interesting about this on the right side here is that enterprises report that most of their data is roughly 50-50 external and internal business sources. So that's very interesting as well. But let's think for a second about how data is created. Data is very much like a drop of rain, if you think about it. It forms instantaneously in a cloud, but as that drop falls to earth, it takes a long time before it makes a ripple. And that's a little bit what it's like with enterprise data. It originates in real time in an application, but the analytics usually is done way, way downstream, and it's often too late. It's got to be real time. The problem with making things real time is the observation that all data does originate in real time. Just think of your applications. Someone clicks on a button, if a transaction is created, if a business process kicks something off, all of that data actually originates in real time, but the analytics to gain those insights is done much, much later. The analytics has to be pulled up. There's no reason why anyone should have to wait on doing these analytics, and again, that's what a platform that unifies both batch and real-time analytics like Spark, that's what makes that exciting. The key observation to think about is that any insights gained from that data is perishable. You have time to act, and if you don't act on it, you're just wasting your time with those insights. Now notice I didn't say that data was perishable. You know, I don't like it when I hear people saying, oh, data loses value over time. Actually, no. That's how you build machine learning models with all that experience data. But the insights gained from it can certainly be perishable. And at Forrester, we've created this perishability framework that you can see here. And you can see the time frame on the axes here. Real-time insights, operational, performance, and strategic insights. Strategic insights, you have more time to make those, strategic shifts. But the real-time insights are what focus on the everyday experiences with the customers and business processes. And this is where companies are trying to get to, trying to take advantage of those real-time insights. But to do that, your analytics operations have to be sped up dramatically. And most are too slow. And why are they too slow? Well, they were designed in the era of the data warehouse, where you integrated data, and then you did some reports, and then those reports were and dashboards were sort of distributed, and they may or may not have been useful. And often, actions were taken based upon those analytics, and sometimes those actions you could not trace back the business outcome. They may have actually been harmful, right? So everyone has to. So companies that want to become a real time, they have to compress that analytics time to insight to maximize that value of the data, to maximize the value of insights. And the interesting thing is that Apache Spark kind of unifies both streaming and batch analytics because you have to have all of these bases covered, all of these insights covered. It's not just about one or the other, because the batch analytics informs the streaming analytics, and the streaming analytics informs the batch analytics. So one of the things I always tell people, and this is what I hear from enterprise architects and developers building these applications, is that you have to think in streams. You have to start thinking real time, and that's actually not how most applications are developed. You get the requirements from the business, and then you see this box here. It says programmed logic. That's basically the code you write to meet those requirements, right? But two important elements are now needed, and one is this real-time context, and that's the context of what is happening right now in the business. Because if you don't have an ability to capture those insights from the streams, from potentially hundreds of applications simultaneously, then you're not going to have real-time applications. And if you also can't create machine learning models and inject that learning into the applications, then your applications aren't going to get smarter unless your team of programmers reprograms it. So I encourage you to think in streams and to think when you design your applications that here's my program logic, but how am I going to inject learned logic and real-time context? We're going to do that through streaming and machine learning. So, our view, and Anand said we just published a wave on streaming analytics, is streaming is an essential technology to identify and act on those perishable insights that, when acted upon, create the real-time enterprise. Let's look a little closer at what we mean by streaming. I think the first thing I want to tell you is what we don't mean by streaming. Now, we don't mean Kafka because that's more about capturing and ingesting streaming information. What specific streaming analytics applications do, like Spark streaming, is that they can also do analytics on that data in real time as it's flowing in. They can act business rules. They can run predictive models, all while taking in simultaneously real-time feeds from one or more applications. So the way to think about streaming analytics, it's sort of the brain. It's the real-time brain. And, calling it analytics is a bit of a misnomer because it certainly is doing analytics, but it's not doing it in a sleepy sort of way, the way you might think of batch analytics. It's real-time, and it's injected into applications. So if you look at this diagram here, there is definitely an ingestion piece. And if you look at those left sides, like the external feed, enterprise application, that can come from direct feeds from applications, or it can go through a messaging infrastructure like a Kafka or something. But it's the streaming engine that really shines. And these are very stateful analytics. They can detect patterns in times. They can detect changes in a time window. That's essentially the engine that detects those perishable insights. Now, when we did our wave, we analyzed streaming analytics platforms in the market, a lot of commercial platforms by some of the big vendors, several startups, open source, including Spark. And a lot of people say, well, where is Spark streaming in that wave? And then we point them to StreamAnalytix, because StreamAnalytix, you'll hear from Anand, uses the Spark engine underneath to handle this. So certainly workload scalability is important, but so is latency, right? Because depending upon what that business time means, if it's milliseconds, then latency is important. And fault tolerance is important because this isn't an analytical run that you run, and if it fails, you can run again. No, it's injected into the operation. And then the other thing I'd point you to is these analytical operators, because these really form the heart, the intelligence of streaming analytics. Now, Spark is it's a great platform, but it's programmatic based. So you have to program all of these features, but in the past couple of years, tools have emerged that sort of abstract that. I mean, the bottom line is productivity in developing workflows within Spark. So when you're looking for solutions needed to accommodate perishable insights in the real-time enterprise, few requirements here. They have to ingest structured and unstructured data from multiple sources in real time. So directly, I guess that's an obvious one. Scale to handle the volume and especially the velocity of the data. It's not good enough to queue this stuff up, right? Because if you queue it up, it means you're delaying the analysis. And if you're trying to do a real-time business, if it's queued up and you're waiting 5 minutes before you can analyze it, the opportunity could be lost. So it's not just about the volume. It's certainly about handling the velocity. Has to be able to process and analyze this in a scalable fashion in real time. So cluster environment is essential here. And like I said before, this has to be fault tolerant because these are for applications. Real-time enterprises for real-time applications, and then tools to monitor, manage that platform, the enterprise features, and tools to visualize some of these insights for users where those insights aren't directly used in applications, and capture whatever that perishability window is, whether it's a second, whether it's 100 milliseconds. It has to be able to find those insights at low latency and offer all of the analytics necessary. Now, many of the analytics in streaming analytics is stateful because it's looking for a time window. And beyond the scope of this webinar to get into sort of the details of what that means, but remember it. Remember that the analytics are stateful because that's important in having the capability. And developers have to be able to build applications, test, deploy, change these applications in the platform. So, one of the great things about the big data market, it's very much driven by open source, by community innovation. And I think it's fair to say that Spark has really, come to the forefront as the most popular platform for this. But we should talk about, well, where does Hadoop fit in? Well, think about it. Hadoop is designed for volume. It was designed to scale out architecture for disk space storage, beautiful for batch analytics, right? Now, Spark came along, and it was designed for speed. It's primarily an in-memory platform. So that's why both of these platforms are often deployed together. And if you buy a commercial distribution, MapR, Cloudera, Hortonworks, it often is delivered with both of these together, because if you're running batch jobs, you can get the files from Hadoop, run them fast in Spark. But Spark also has some other application. Hadoop and Spark are definitely friends. They have been. But Spark is really where developers go to create real-time enterprises and real-time applications. Hadoop is not, that's not what it was designed for. It was designed for volume. Spark was designed for speed. So Spark is where the action is. It's designed to process in memory. It can spool to disk if it has to, but it's designed to process in memory, and accessing data from memory is 58,000 times faster, roughly, than accessing it from disk. So Spark, it also uses a DAG engine, and that optimizes the parallelization. The end result is Spark is faster, not just because of memory, but because of the way the engine works as well. So Spark doesn't need Hadoop. It just needs great compute and storage. So in that way, Spark is also data agnostic. So you don't actually need Hadoop to run Spark. And Spark has also become enormously popular because it's not just this general purpose cluster. There's Spark SQL, there's Spark Streaming, which we're very interested in here today in the real-time enterprise. There's machine learning, and then there's also a graph network. So you can not only do anything you want because it's a generalized platform, but it comes with these solution accelerators, these capabilities that allow developers both batch and real-time opportunities. You may have heard of the Lambda architecture. The Lambda architecture has a speed layer, and then it has a batch layer. And as you saw from our diagram here, both are needed because you need the insights and the hypotheses and the models that you get from batch analytics, but you need the real-time analytics. So you need to unify these two things, and that's what's exciting about Apache Spark, especially because it's use cases. Now, a lot of the people that inquire about Spark, you've got enterprise architecture, certainly, developers, the CIO's office. It's pretty much a technology that most large enterprises are adopting, and some of them just for the left side, the batch analytics side, but more and more accessing it for the real-time side as well. So the real-time enterprise is all about how fast you can do things. It's all about the amount of time it takes to do things. So enterprises in general need to stop wasting time and instead use it to their advantage. So I thank you, and Anand, I'll hand it off to you.
Thank you very much, Mike. It was delightful to hear all of what you said about Spark, particularly, right? Setting the context for real-time streaming analytics and then about Spark, because we're going all in on Spark, and it seems like enterprises are going all in on Spark as well.
Yep.
So before I move forward, Mike, I just wanted to get your impressions on whatever you can share on, are enterprises really showing that kind of interest and focus on Spark? Are they telling you, look, we're implementing this, we're doing this or that, et cetera?
Yeah, I actually did some research on this. We produced a report called "The Future of Hadoop is Cloudy," and part of what we found in that research and talking to the largest of enterprises is that there's more interest in Spark, and they're writing jobs that run on Spark than on Hadoop. Hadoop is very much a storage medium. And people would famously use MapReduce, but now they're rewriting or writing new jobs directly in Spark. But, Anand, again, a lot of that has a batch orientation, right? Because Spark is very good at the batch orientation. What we haven't seen as much, but we've seen an uptick in it, is using the streaming analytics. Now, most of the inquiries I get about streaming always include Spark streaming. So we know it's on people's mind. We know they want to understand its capabilities. So we expect, with this push to the real-time enterprise, that the uptake and the adoption will be much faster.
Excellent. Thank you. So let me cover our portion and tell you a little bit about StreamAnalytix and how it does Spark and how it does stream processing and how it enables the real-time enterprise. As you can see here, StreamAnalytix is a product that really its mission is to enable the real-time enterprise. And we do real-time stream processing and machine learning. And like Mike said, sometimes when we say, we don't like to say real-time stream processing sometimes, because there are people who actually land data from IoT feeds into file systems, and it could get picked up half an hour later, et cetera. We have agents that take those data and stream it out. So it could be it's streaming data, not always real-time and near real-time, sometimes a little older data as well. But the point is to try and stream everything in as soon as possible. Just to cover a little bit about what this product is and what Mike himself has said about this product, StreamAnalytix, in the Forrester Wave, the key thing to note is that we seem to have the opportunity to make StreamAnalytix the de facto tooling standard for Spark, and says, covers open source bases without the headaches, architecturally positioned to support both open source streaming, other engines as well. So we have support for Storm and Spark, and then we, of course, have support for other engines. We have SPROTEC embedded in it for complex event processing, and like Mike said, unifying streaming and batch is critical, and enterprise-grade visual tooling is critical. Anything at all you want to say, Mike, for just a second on what you observed on the whole landscape of products and how thank you for mentioning, by the way, that, when people ask you, we found that really interesting when people ask you, hey, what about Spark? And you said StreamAnalytix is Spark, so go look at that. So thank you for that.
Yeah, because like when we do a wave, readers, they want us to evaluate the open source, but you can't just say, that's like it's an Apache project. So Apache isn't offering a product per se. So what we do is we look for enterprises who use open source technology as its key engine, and that's why we chose you to represent Spark in the streaming wave.
Excellent. So thank you so much. So a little bit about StreamAnalytix before I cover the enterprise case studies where really the rubber hits the road. So StreamAnalytix does two things. We started actually seeing that besides being a real-time streaming data analytics platform, after we added Spark batch capability, the enterprise demand actually went up because people are doing a lot of batch. They get in, they like to know that, hey, I got a Spark-based platform to do my batch jobs now. I know I got streaming jobs coming up in 6 months. Why don't I just use one platform because this offers me the roadmap. So it does real-time data analytics as well as making Spark easy in general for general-purpose Spark workflows. And on the real-time front, it's really all about compressing that time gap or time delay between various stages of where data arrives into the enterprise, where it gets integrated, ETL, and then it gets into a data mart, etc. So you're really compressing the delays of data from hours and days to seconds and milliseconds. And this is a very interesting chart because we really want to say those of you who are looking at speeding up, and when we say enabling the real-time enterprise, it can be in different stages. You could be in doing Hadoop MapReduce or other non-big data technology-based slow processing jobs like ETL jobs running on a big database like Teradata, etc. You could start moving those jobs over to Spark batch, and that will obviously, all the batch jobs will execute much faster in memory, even if it's a matter of training machine learning models, for example. In fact, that's where AmpLab started Spark. to actually have a scalable machine learning framework in memory. You can then go to the next step of Spark streaming with faster, which is obviously faster than doing Spark batch jobs because it's micro batch. And if you don't have a latency requirement to turn around and respond to an event in less than half a second, you're still safe with Spark streaming. Then the fastest and the biggest, the ultimate distance you can go in terms of the scale of speed and latency is event stream processing, which is what some people call it. And that's where really it's true event stream processing with Storm and Flink and those kind of technologies, where you're really doing streaming analytics per event, every event coming in, every little sensor data coming in from a big machine. You can look at it individually, analyze it, and respond to it. So that's the spectrum of moving towards real time. And the kind of use cases that we have enabled for customers and are very popular are here. There are customer-oriented use cases, customer 360 and churn, real-time churn, like Mike mentioned before. Recommendation engines are next best offer or action. This one is catching a lot of attention these days, real-time call center analytics. The call center managers somehow want a more deeper and deeper real-time analytics on what is happening, what's the average call hold time, key metrics in the call center. IoT and log analytics is obviously very, very huge. When I say log analytics is not associated with IoT, these I've kind of combined some of these just for convenience. IoT is a whole world in itself, right? Smart factory, smart home, warehouses, data centers, all of that, including vehicles, connected cars. And log analytics could be application performance monitoring, any kind of IT scenarios where there's log analytics to perform. We're seeing a lot of fraud and risk and anomaly detection. In fact, we had an interesting conversation recently, Mike and I think there's a serious potential for anomaly detection as an area in itself, and we are investing into it as well. We're moving towards an automated data science capability for anomaly detection. And of course, one of the areas where that's useful is predictive maintenance for high value assets. And of course, cybersecurity, we're doing insider threat detection and a number of different cybersecurity use cases. So the stack that we have, we've mentioned it before, but it's essentially a message queue like Kafka, RabbitMQ, or any other ones. We have just mentioned Kafka just because it's most popular. But that's just a message queue, like Mike mentioned, right? It brings in the data, and then the data gets analyzed using either Storm in Esper, or Spark streaming. Either way, of course, Spark is much more popular now. Storm is somewhat fading away. And the next engine we're looking at is Flink. So Spark ML, MLlib, et cetera, are all packed into the Spark infrastructure in our product. And the beautiful thing is we added PMML capability, where you can bring in models from other places like SAS or R. They can export those models and score them on Spark. And H2O and Python are also very popular. We can score H2O, Python models, et cetera, in Spark. And the really cool thing about StreamAnalytix as an analytics platform is that both learning and training and scoring can be done both in real time and batch. So batch learning, batch scoring is pretty normal. That's been around for a while. And real-time scoring is all about taking a model and running it on live data. For example, when I make a real-time recommendation on, you're on a website, what are you likely to buy, what ad to put to this customer, what to offer to this customer at this point, based on where he is, what he's doing right now, or what he did just a few seconds ago. All of that kind of recommendation is real-time scoring. Somebody's asking about real-time scoring in terms of Q&A. And real-time learning is bringing in that feedback in a live mode, right? When people click, or in an anomaly detection platform where we're logistic regression or linear regression or k-means clustering, there are three or four different algorithms that can do real-time learning and model improvement as they're scoring. So all of that is now available in StreamAnalytix using Spark. And of course, we can go into more details over a private demo. Let me now cover a little bit about the general purpose Spark aspect of it, of StreamAnalytix, right? So first of all, let me set the context here. So Spark is increasing in demand. People want to get projects done fast. There's talent in unavailability, right? There's low talent in the marketplace. We see it as a large company serving large enterprises. We see this every day, where people put Spark on their resume. They want to be Spark engineers, but they really don't. They're not skilled enough. And when it comes to really deploying a production-grade application in a major bank or an insurance company or a major telco or hospital, you really want to have production-grade, very, very reliable applications. And for that, and if you're with the kind of talent and skills that are available today in the marketplace and the kind of demand there is, Spark projects unfortunately get slow and they're difficult, they're costly, they're risk-ridden, etc. Right? So that's really the impact of the lack of adequate talent. So, you want to ask the question, we're talking about enabling the real-time enterprise. How real-time can you get when your projects get delayed a lot? If you can't deliver the use case that the business wants in less than 6 months or 8 months, then, you lost huge opportunities right there, right? So the solution, think about the solution to this problem, right? Is it adding more people? Obviously not, because they don't really exist. That's what we're talking about, right? That the talent's not available, at least in the short term. Do you want to ditch Spark and buy proprietary platforms? Well, you could consider it, but that's kind of going backwards, right, in terms of going back into the lock-in era of large proprietary OEM vendors. So, you could bite the bullet and delay the project. Of course, it's not a desirable option. Hire outsourcing companies, well, where are they going to get their people from, right? The Spark talent availability is an overall market problem. So we feel the solution is really to enable yourself with the right tools and make existing people and teams much more productive. So if you could use 2 or 3 people instead of those 10 engineers that you wanted to hire, or that 3 people, 4 people team of bright engineers you have, if you make them 5 times more productive and have them build applications much faster, and those developers who are listening in, if you can just churn out your application quickly within a day, how would that be, right? That's the kind of tooling you really need. And what kind of tooling would that be? So you, of course, like Mike said, as a platform, you really need a visual interface to make things easy, where you can develop, debug, maintain, deploy, monitor, tune, all of that with Spark pipelines. And functionally, you want to build more and more. What we're seeing is the data 360 kind of approach, where people want to do ingest, ETL, analytics, machine learning, and applications on the same platform, and they want to take it for granted, of course, that they can handle scale, performance, reliability, etc. So that's the kind of capability that you really want to build out as a platform for Spark. And the StreamAnalytix capability is exactly in line with all of that. Otherwise, we wouldn't have been featured for a second time by Mike. I can tell you that he's pretty rigorous about his questions. The fact that you've been on a previous wave does not give you any points. You got to produce 2 new customer references, and they do reference checks. It's a very, very rigorous process that Forrester uses to vet these platforms. There are about 13, 14 platforms that Mike has covered. But here we go on the StreamAnalytix capability, right? So we got the Visual Spark Studio as a core part of StreamAnalytix, and I'll tell you a little bit more about how we've taken that out as a product on its own. But what we're referring to Data 360 here is the full journey of ingest, transformation, and enrichment, analytics, and machine learning, including the stateful time window-based processing that Mike was talking about earlier. It's not just enough to stream data and look at a single event. You've got to have time windows and do stateful things like, okay, if I get this event and I don't get that even for another 5 minutes, then here's the rule or here's the alert you want to raise. And I'll go into specific use cases as well that we've done on these things. So the Visual Spark IDE is available with both streaming and batch capability and Uzi workflow orchestration capability, all the way up until including analytics, loading different databases, and including viewing real-time dashboards. So that's the overall capability set in StreamAnalytix, and I want to show you a little bit about how this thing looks, right? It's good to talk about it, but here the rubber meets the road. this is the kind of interface you'll see in StreamAnalytix and Visual Spark Studio, where you got your interface to build out these Spark pipelines. You got these widgets and operators on the right side, channels, processors, analytics, emitters. Channels are places where data comes in from. Processors are all the Spark API, Spark transformations you can build on them. You can notice there's Python, there's Spark SQL. You can add any kind of custom code as well into this platform, like this custom processor. Both Java and Scala are supported for custom code. So you can use all of the pre-built widgets that we have without writing any piece of code. Just assemble them and then start testing them. What you see on the bottom of the screen is the ability to actually run and inspect a process where you can build out your pipeline and then run a small test of 100 records or so, where you can see from stage to stage in this pipeline exactly what data went in. This is a JSON data object here that shows how the data looked before the stage and after the stage. So you get to debug right there without submitting the job to a Spark cluster, because StreamAnalytix builds in a Spark instance in it. So that's the kind of convenient user interface you get to build out Spark jobs, and you can literally build Spark jobs in minutes without writing a line of code. And here is your overall interface on Spark pipeline. So once you build that pipeline, you zoom out as a super user. You get to see all your different pipelines. You can take actions on them. You see the status here: streaming active, streaming stopped. And as you can see, we got Spark, Storm, and workflow options here on the platform. And then you can take actions on each of these: start, stop, edit, and see the metrics on each of these pipelines. And the business data, when you look at from an administration point of view, it's important to do a DevOps on your environment as well. So you want to see how many cores are being used, how much memory is being used in the cluster, how many pipelines are actually at play. So you get a complete visual on the environment around Spark and all its connections as well. So you're connecting to Elasticsearch, connecting to HBase. What are all the connections that Spark has in your environment? You can observe all of that, performance manage all of that. The business data that's coming through, you want to visualize it in StreamAnalytix. Like I said, you can go all the way up to visualization, and without writing code, you can build these real-time widgets and create real-time dashboards in a quick few minutes. And this is an example of a IoT pressure and temperature monitor here. With you can build min, max, average thresholds on the real-time dashboard. So a real-time dashboarding engine is built into StreamAnalytix. And finally, in terms of monitoring, that's very important as well. So we got monitoring capability on the pipeline, including errors, application errors, infrastructure errors, again, built into the platform. So you can monitor and visually create alerts on your Spark pipeline. If throughput goes up and down, you can alert yourself and take actions. So as you can see, it covers the full journey of design, development, debugging, monitoring, deployment into a Spark cluster, and then monitoring your Spark pipelines, right? For those of you who want a physical view of, hey, how does this thing look on the cluster? Where are you based? And where's the cluster, et cetera? Here's the layout. StreamAnalytix is a web-based container application which can be deployed on one or two servers, edge nodes, that can see and connect to the Spark cluster. It could, of course, this whole thing be replicated on the cloud or on-prem. The user is the web-based user connecting to the screens that I just showed you. And once the job is ready, once you test it, you submit it to your Spark cluster, and either any Hadoop distribution you have will work, and on the cloud as well, this will work. Okay. So coming to the Visual Spark Studio in a couple of minutes before I get to the case studies, I just showed you what the enterprise edition of StreamAnalytix looks like with the full cluster deployment. You can download Visual Spark Studio, which is a single desktop version of StreamAnalytix, onto your desktop in a few minutes and get going. If you want to test this out, it's free. You can download it and start using it. And you can even deploy pipelines on a single node. And when you get ready to submit to a big Spark cluster, then you need the enterprise edition of StreamAnalytix. So you can just go to the website streamanalytix.com and then download it and test it out. So let me tell you about how real companies are using this technology in terms of Spark and StreamAnalytix and what they're doing with it, right? The point here is this gives a leap of advantage, a business advantage to customers. We're saying why improve, why that 20-30% improvement when you can entirely transform your business. And when we mean transform, when we say transform, we mean creating that real-time enterprise, operating in the now. The application architecture that Mike just talked about, where applications are sensitive to the current context of consumers or machines, et cetera, and able to react in time. And transformation also means for us dramatic nonlinear increases in performance and cost trade-off, like 5-10x performance from the same amount of hardware, right? Net new capabilities or revenue streams that were previously not possible. These are also possible with real-time streaming analytics. So let me tell you about a couple of stories here, right? A few stories which are real success stories here. So one of the top airlines in the U.S. that we all have flown is boosting their customer digital experience. They're funneling all application data, whether it's mobile, web data, et cetera, onto an enterprise bus, and we pick it up. StreamAnalytix picks it up from there. They earlier could not handle anything more than 3 days because the amount of data that was getting generated from those applications, they didn't have more than 3 days analytical capability. We went in, put in a pipeline with StreamAnalytix and increased the capacity to like 3 months of data where they can correlate events and patterns across a large time window. And that resulted in much faster and more effective issue resolution. And the foundation has also been laid for real-time machine learning and predictive analytics. And what they did is, of course, the data velocity is 7,000 events per second, up to 5 terabytes per day. We're taking data through Kafka, filtering it, enriching it, applying rules on it, and then landing it at Elasticsearch. And there's a live diagnostic tool that people are able to use on Elasticsearch in this application. Very, very simplistic application pattern here that a lot of people are doing, but this is proved to be the first step, and there are like 4 or 5 different use cases that are coming up on top of this for application performance monitoring. And you and I, when we use that mobile app of this airline, or when we're on the selecting our seat online and checking in, looking at our boarding pass, all of that experience being monitored by these events. Next case study with a major bank is an insider threat detection application where this bank got about 5 times greater performance from just the same hardware. It's like a handful of nodes, 5 to 6 nodes of Spark-based nodes. And this was a very unique deployment for us because we didn't use any Hadoop infrastructure at all. It's actually running Spark live on those nodes without any virtualization, and it is directly inserting data back into Kafka. It's going downstream into another application and also into SQL Server. So we can onboard 5 times more application traffic for detecting threats. And insider threat detection is a big deal. You and I trust these banks to be safe with our data and our information, and insider threat detection can be essentially threats of information security from inside the bank with employees, right? This was the pipeline we ended up building for them, where people are doing ingest. We're doing ingest from Kafka. We're doing deduplication of the records with a 7-day, record. So we maintain records for 7 days, and any duplicate records we eliminate. And then we filter duplicates and we eliminate duplicates. We do a data quality score online. We filter unique records and then do the whole insider threat detection modeling, and we raise those alerts. We send that into another file into an HDFS, etc. So as you can see, there's very, very little custom code here. This was built up in 4 to 6 weeks and went into production. It was the fastest among multiple vendors that we went into production. And people took years or many, many months or quarters to build out this to a production-grade quality. We went in there 4 to 6 weeks. We were done, replaced the existing technology with 5x more performance. With a big pharmacy business processing giant, we're doing a real-time change data capture flow from Oracle transaction tables into creating, writing them into Hive reporting tables. Again, there's hundreds of source tables that need to be moved over to Spark and Hive eventually. And this manager said, look, based on the productivity I've seen, we ended up delivering 2 mission-critical data pipelines in 1 day and 2 days respectively. So with three business days, we ended up delivering this whole thing, and people said, they get a feeling that they could do with 2 or 3 engineers, they could essentially build out all of their, port all of their manually written Spark code, et cetera, onto this platform and start managing that. The case here was Oracle-based transactions and moving to Hive-based reporting tables. And we partnered with Unity for the change data capture. We consumed Unity feed from Kafka, and we did de-normalization and then wrote into Hive. There were multiple stages here. For want of time, I'm going to cover so data de-normalization, read, data ingestion and staging, data de-normalization, and then writing. So 3 or 4 different pipelines were built on our platform. So Unity feeds to data enrichment, and we wrote into HDFS. And then we did reconciliation. So we joined the HDFS tables with the static tables, the incremental data that came through from Oracle. We did the join and did outer join and merge onto HDFS. That's another pipeline. That's the second pipeline. This is the de-normalization pipeline. And the third pipeline was incremental updates, right? Merging those updates and flattening out the entire table onto Hive and feeding the reporting interface. So that whole feed, and they have now an infrastructure that they built. This whole set of pipelines was built in about 3 days, and now they have real-time transactions landing in Oracle, moving straight into reporting tables into Tableau in real time, and they're able to manage it all visually, right? And there's Uzi workflow-based orchestration here as well. So these are some of the case studies that we have. I'm going to skip past the hosted call center use case. We've covered this in other webinars before. Brilliant use case that people this company now has. Let me show you this piece here. This company now has the capability to add a new revenue stream for their end customers. And people are seeing this, insurance companies are seeing this use case. They're getting really interested, and anybody who has a call center is going to be very interested in this kind of real-time call diagnostics capability, which impacts customer service. Let me go to, and these are the real-time visualizations that we built where, this is one last thing I'll do before we go to the Q&A here. These are events coming in from call records all over the voice over IP network. When you and I get on a call center call, we get bounced from one agent to another agent. We get on the IVR system. 8-10 different boxes are handling this call, and they were looking at these records, and they were unable to do correlation and debugging in anything less than a few hours. And now this is all instantaneous and in real time. This is the inbound portion of the call in blue, IVR, and outbound in red and green. So each of these is a 0.08 seconds, 0 seconds. So at the millisecond level, we're taking events and we're stitching all of them in memory and then registering them in Elasticsearch and visualizing that here. So anywhere where you have event-based correlations and time windows and stateful processing, you can use this kind of infrastructure. Let me go to some questions here, and please feel free. That some people are asking good questions. Keep them coming, and we'll start to address them now. First of all, Mike, before we go to the questions, would you please, audience, please go to the poll on the top, on the bottom right, and answer the poll. We'd be very, very interested in hearing your feedback. While we answer questions, feel free to give us your feedback and tell us more about what you think about this webinar. Okay, thank you. Let me go to the questions now. So, Mike, can you compare Spark streaming to Kafka streaming in depth? This is a favorite question of yours, I guess, that you're getting a lot. That was the first question we got.
Yeah, so Kafka comes from solving a different problem. It's trying to solve the problem of ingesting data and then making that data available to multiple consumers of that data. So it's more about it's more of a messaging infrastructure. Now, once you start ingesting data, then people start asking the question, well, are there other things I can do with this? Can I do some light transformations? Can I do some analytics? So the key thing to know about Kafka is that it's a great infrastructure for ingesting data, but it has very light analytical capabilities. Now, the streaming analytics market and technology comes from a very different pedigree. It really comes from complex event processing for really low latency analytics and pattern detections on Wall Street for algorithmic trading. So it's just fundamentally a different technology. It's different in the way it has to scale. And, I mentioned in my part that analytics need to be very stateful. So might as well give one tiny example. It might help people understand what that means. Let's just say you're getting data from, let's do an IoT example. You're getting temperature data from some device. So it's pretty easy to think about how you could push those temperatures onto a Kafka queue, and then you could pull something off that looks at those temperatures. But what if you weren't interested in just the temperatures, but you were interested in the rate of change over, say, a 10-second period? That's where a stateful analytic comes in, because now you have to keep track over the last 30 seconds, what is that change? So if you sort of extend that to all the different types of stateful analytics, it's fundamentally a different technology. So, Anand, as you said, Kafka is great to act as a feed from sources, although streaming analytics doesn't need that directly. But analytics is a very specific technology, and there was no Kafka-based solution in our streaming analytics wave for that reason.
Excellent. Got it. Thank you, Mike. Thanks for that clarification. Let me take this one. It's a question on real-time scoring. Can you talk more details about how real-time scoring procedures, et cetera? So when we said real-time scoring, it's nothing but you have a model, you already built the model, trained the model, or it is a learning model in real time, which can also be primed up before it starts scoring. And scoring is nothing but, using the model and making a prediction based on the incoming data and saying, okay, this customer just came in to the website. What ad do I show him, right? And is the potential likelihood of buying this particular product on a score of 0 to 1? So that's real-time scoring, and we do that at scale using Spark in StreamAnalytix. That's real-time scoring. So the next question about data governance across architecture, privacy and ID assurance, traceability needs to be in the ingestion and across the flow. So since we have Mike here, I don't want to hog the answers. Do you see that as important? What strategies do you think, Mike, on data governance and data flow, metadata across all the entire pipeline end to end? Anything you want to comment on that?
Yeah, I mean, I think people are realizing that it is still important. And, what I mean by that is sort of the old data integration with ETL and data warehouses. Governance was one of the key pillars of being able to do that. And I think people initially thought with the open source platforms that for some reason you didn't have to do it. But you do, and the awareness of that is increasing, because the need is the same. You need to have data quality. You need to know where the data is coming from. You need to describe the data, because when you're bringing data in from multiple sources, there's often the need to create some sort of unified model of what that data looks like. So governance processes, there's nothing about Spark or Hadoop or any other platform that doesn't require good data hygiene.
Right. So from a product and platform implementation point of view, I can tell you that we give a good amount of attention to that in combination with the Hadoop distribution itself that has metadata and governance tooling built in. We integrate with those tools, and we do traceability of data across the across the Spark pipeline. So if you want to see a particular credit application got declined for some reason or got approved, and for a regulatory aspect, the bank needs to go and look at that particular application, that particular data point, and how it went through the pipeline, we can show in our pipeline step by step the complete what we call the lineage of the data point, and seeing how it got enhanced, which model got applied, when did it get applied, what data was used to say yes or no to that particular credit application. And that would be a great case of complete end-to-end metadata traceability of lineage. And we would, from a security point of view, we hook into LDAP and enterprise repositories to do the user access roles and security permissions of who can build pipelines, who can see them, who can stop them, etc. So that whole data governance architecture should be well integrated in your enterprise with your enterprise systems as well as the Hadoop data lake. So next question is, can these Spark jobs be incorporated with enterprise job schedulers? Yes, we talked about Uzi just now in the presentation. We can integrate with other schedulers on a custom basis, but it's integral. When we say Spark batch support, we really are talking about being able to integrate with job schedulers. Mike, let me have you address this. How does Apache Spark fit in with cloud PaaS offerings like Microsoft Azure? What do you see about that in your wave process or otherwise?
Well, Spark certainly can be deployed in the cloud, and all of the major cloud companies have a provision for doing that. Usually under their Hadoop deployment, Spark comes with that. I mean, the opportunity and the thing to think about in the cloud is auto-elasticity. So that is the ability to provision, and when you need more power, to deprovision to optimize the cost.
Got it. All right, great. Pankaj, we should be closing the webinar at this point, I would say. Thank you so much, audience, for your participation. And Mike, thank you so much for your time and participation here and all your wisdom. Look forward to having you more with us in other events. And audience, thank you so much for your time and attention.
Thank you, Anand. Thank you, audience.
Thank you.